Hi, this is Kyle, and this is my final project for Data 620. It's a project involving multi-class text classification using Yelp reviews. Yelp conveniently provides a large amount of its data to the public for non-commercial purposes. And we're going to experiment using a bag of words approach uh, to doing machine learning classification models. And we're going to, in effect, see if we can try to build a sentiment analysis classifier between the ratings and the review text. And before we continue, I have to mention that a lot of this analysis was inspired by Susan Lee's writings at towardsdatascience.com. So in the original review dataset, there were 6 million reviews. But I decided to cut down on some of the noise by filtering to only the reviews where at least 10 other Yelp customers have deemed the review being useful. And that left us with 33,000 reviews for our experiment, for our analysis. And the response variable that we're going to try to predict is the star rating. And we have some imbalanced classes here. The best rating, 5 stars, being the most frequent in the set, followed by number 4, then number 1, then 3 and 2. And this is where I decided to pull the most useful review from each of the star ratings to read them and look for some ideas about what we might, some features we might engineer. And some of the things I gleaned from this is that we might consider using exclamation points as a feature instead of removing that. And also some of the common words that are negation, like no and not, that would normally be removed as being too common in our stop word set. Also, I was wondering if possibly the length of the review was correlated with the star rating, but I looked at the median length for the reviews by each of the stars, and actually the 5-star was the shortest, and the 2-star was the longest. And next, we go from the raw data to doing some feature engineering and text munging. Of course, we converted everything to lowercase. And we're going to replace the exclamation point with this word, exclamation point here, to see if this is a relevant feature to our modeling. We replace the contractions that are negative with the word not and no. And we also kept in the analysis these negative stop words that we would normally remove. And we kept only alphabetic tokens and tokens that were at least 1 character long. And then we used the Porter stemmer, which is the most conservative of the stemming models. And this is and the result of all of this normalizing of the text was we decreased the unique word count from 120,000 to 43,000, which was a 65% reduction. And this is what the review now looks like. So for our first set of models, we're going to use Unigram document term matrix, where each row is a document and each column is one of our tokens. And we're going to use inverse or term frequency inverse document frequency, also known as TF-IDF, as a way of selecting, as a way of weighting the terms by importance, essentially. It looks for how important is the term within a particular document and how important is the term in the entire corpus. And we also set a minimum document frequency for our matrix to be 0.1%. And so after this, we have 5,700 features in our matrix. Now, let's take a quick look at the chi-squared statistics of some of the top terms by class. And let's see if they make sense. And they kind of do. In the 1 stars class, we have refund, worst, money, manager, rude. And in the 5-star, as well as in these other ones, we notice the exclamation point is kind of high, as well as great, best, awesome, love, lash, and highlight. We're not entirely sure why the not word is in the 5-star among the top 5-star terms. For our unigram, for our modeling, we're going to use 3 models: linear support vector classification, multinomial naive Bayes, and multinomial logistic regression, which from my research is also known as maximum entropy. And we reserve 25% of our reviews as a test data set for the end of our presentation. And then we did 5-fold cross-validation on our sets, on our matrix. And when we did that, we see that by far logistic regression has the highest mean accuracy of the 5-folds at 64%, followed by linear SVC and then naive Bayes. And we also see that the individual fold accuracies aren't too varying. So we know we're not just fitting to random folds in the data. Now, let's try and see how our models fit if we switch to using bigram matrices. And so we basically used scikit-learn's TF-IDF vector class in order to create a matrix where each of the features is a bigram, 2 words. And so we created one that has nearly 5 times as many features, 25,000. And let's look at the top bigrams per class, and we see that they all make sense for the most part. We have some double exclamation points in some places that are really important. And then we also see where in the review text they actually say 0 star. And let's see, 2 stars, I think I saw. Yeah, 2 stars right here and 3 stars. So, of course, that would be highly correlated with the class. And the results of our model fitting is that, again, logistic regression came out on top, but everything was much lower using the bigram features. Now let's try the same thing with a trigram set of features, and this time we're going to use 36,000 of them. And these are the tokens. They all look pretty good. And when we perform trigram cross-validation, we actually have naive Bayes come out on top this time. But again, all of the mean fold accuracies are lower than the bigram models. So let's look at what we can conclude from this. We see that down here, this is a weighted heat map. And we see that we definitely were able to predict the 1-star class with a lot more accuracy than any of the other classes on the diagonal, followed by the 5-star and then the 4-star. So it seems like the ratings at the extremes of the classes are more easy to predict. And our overall test accuracy was 63%. So it was a little less than 1 percentage point smaller than our cross-validation accuracy, but not too far away. So we didn't overfit too much. And then finally, we can look at our weighted F1 score. It was 64%.